An experiment with a river built in a lab suggests that geological histories around the world may need to be rewritten. Waterfalls are furious cascades of water, sometimes scoring the landscapes in which they flow as they obey gravity's demands. From Iceland's shimmering Skogafoss to the family of falls in New Zealand's Milford Sound, they are zealous, aquatic showstoppers of the natural world. Powerful though waterfalls may appear, there is a long-standing assumption that they can only form when permitted by other natural forces. Tectonic movement shifting rock around, alterations in sea level, a change from a resilient rock to a more easily erodible one are all ways in which external forces are believed to influence where waterfalls form. But this paradigm may be about to change. By building a scaled-down river in their laboratory, a team of researchers demonstrated that waterfalls can sometimes bring themselves into existence without any outside help. Scientists often use the presence of waterfalls to try and reconstruct the history of a landscape, said Edwin Baines, a quantitative geomorphologist at the University of Auckland in New Zealand, and who was not involved in the study. By better understanding how waterfalls can form, the new study may prompt scientists to reconsider how our planet shaped itself, and help them peer back through deep geological time with greater precision. Although there had been suggestions in the scientific literature that waterfalls could self-form, it wasn't clear how that could occur. This new experimental evidence, said Dr. Baines, provides a very convincing explanation. To investigate how waterfalls form, researchers built a 26-foot-long, 12-inch-wide, 3.3-foot-deep channel. They filled it with a foamy bedrock, tilted it at a 20% slope and let sediment-rich water flow down its surface. By using a riverbed made of foam rather than real rock, the team were able to watch millenniums of erosion play out under very short timescales. The turbulent flow of the river down a steep slope started digging out parts of the riverbed. It did so unevenly, with some pockets eroding faster than others, and the uneven erosion was amplified as the river continued to quickly flow. Eventually, with no externally triggered changes to the sediment load, the flow rate, the underlying channel shape or anything else, a deep pocket of erosion formed, one that made the river jet off from the higher section of the riverbed and splash down some distance away. A waterfall appeared, all by itself. Scientists had assumed that waterfalls always arose from geological or climate-driven changes. Now, I think we're starting to call that idea into question, said Joel Scheingross, an assistant professor of geosciences at the University of Nevada, Reno, and the lead author of the study, published Wednesday in Nature. The research could contribute to our understanding of Earth's landscapes. By incorrectly attributing the formation of waterfalls to external forces, scientists may be picking out erroneous climatic or tectonic signals, said Kate Leary, a fluvial geomorphologist at the University of California, Santa Barbara who was not part of the study. Developing a way to discern self-formed from externally forced waterfalls would be very beneficial for teasing out these signals in tectonically active landscapes. The results of these experiments suggest that the steep, upstream sections of rivers in mountain ranges around the world may be particularly likely to feature self-forming waterfalls. If so, the geological histories of some of these elevated realms need to be re-examined. Dr. Scheingross said that more research needs to be done to shore up his team's model. But if their hypothesis is supported by additional evidence, then the genesis of waterfalls is a more complicated picture than we originally thought, he said.